This video is for section 6-5, quadratic functions and variation. Of functions whose values are given by this polynomial, where a, b, and c are real numbers, is called a quadratic function. So notice the quadratic function has highest degree of 2. The simplest quadratic function to evaluate or to graph has this format. So there's no x term and no constant term, just the quadratic term. Here's an example. Show some ordered pairs and graph y equals x squared. This is the simplest of all quadratic functions. Here in the chart are some values for that function when substituting different numbers in for x. It's a little blurry on the video. Hopefully you can read it on your paper if you squint. So -3 to the second power is +9, -2 to the second power is +4, and so on. You'll notice some repetition, a +9 and later a +9, a +4, later on a +4. There's one number that's not repeated, the number 0. When you graph those ordered pairs, it creates the dots that you see in the middle figure. And if you connect the dots, you create the parabola that you see in the last figure. That shows the graph of the function y equals x squared with an infinite number of points on them. Hopefully you notice some things. What do you notice about the ordered pair solutions? Well, we already commented about that. Except for 0, 0, two different x values have the same y value. When x is -1, the y value is +1. But when x is +1, the y value is +1. What do you notice about the placement of the points on the graph? No doubt you notice one point at the very bottom of the graph and how the rest of the points appear to come in pairs. One point to the left of the y-axis line and a corresponding point to the right of the y-axis line. At a height of 4, one point is 2 units to the left of the y-axis and a corresponding point is 2 units to the right of the y-axis. There appears to be symmetry where the y-axis line is the line of symmetry. What do you notice about the vertex point? In this case, the vertex point is located at 0, 0, and it is the minimum point. What do you notice about any symmetry? Well, we already commented about that there appears to be symmetry with the y-axis line as the line of symmetry. Left of that line is the mirror image of what's to the right of that line. The vertex point of the previous example showed the function's minimum value, so it's called a minimum point. A quadratic function might have a maximum point instead of a minimum point. In which figure below is there a maximum point? And hopefully you identified this third figure where the vertex is located here and it is the highest point on the graph. Here is the equation that resulted in that parabola. Notice that the leading coefficient of that equation is the number -3. Also notice on the other two parabolas where the vertex is a minimum point that the leading coefficient is a positive number. So let's follow up on that. When a is less than 0, meaning when the leading coefficient is negative, there is a maximum point. And when a is greater than 0, there is a minimum point. True or false? The vertex of a quadratic function lies on the axis of symmetry. That's true. Here's an example. If the variable v varies directly as the square of s, and s is 4 when v is 48, find v when s is 6. We have a varies directly situation. There are two ways to address this. One is with the model, where one variable is equal to m times the other variable. And we're told that v varies directly with the square of s. So this would be s squared. Then we can substitute known values for v and s to solve for m. We're told that when v is 48, s is 4. So 48 is equal to m times 16. And dividing by 16, we get m equals 3. So our model is v equals 3 s squared. Now we're asked to find v when s is 6. So replace the s with 6 and evaluate. 6 squared is 36, and 3 times 36 is 108. So that's one way to figure out a direct variation situation. The other technique we used was the proportion. We're comparing v to s squared. When v is 48, s squared would be 4 squared. Then it says find v when s is 6. So s squared would be 6 squared. We could rewrite this as 48 over 16 equals v over 36 and solve it with cross multiplication. 16 times v equals 48 times 36. Divide by 16 and you get 108. Let's summarize this lesson. We discussed quadratic equations, equations with degree 2. The simplest quadratic equation is y equals x squared. We looked at a table of values for that and how you create a parabola shape when you graph those values. A parabola has a line of symmetry, and on that line of symmetry is the vertex point. The rest of the points come in pairs, one dot to the left of the line of symmetry and a matching dot to the right of the line of symmetry.